Alright, so hello and welcome back to the continued coverage of the walkthrough series. And in this episode, we're looking at 9618 variant 41 of June 2023. We'll be doing the Python implementation for question 2. So it says here that a computer game is being designed that will include different vehicles. A prototype for the game is being developed using object-oriented programming. The class vehicle stores data about the vehicles. Each vehicle has an identification name, a max speed, a current speed, and a horizontal position. The value increase amount is added to the current speed each time the vehicle increases its speed. So here we are given the class diagram for the vehicle class, as it were. You can actually see the attributes right here. So there's actually 5 attributes going on there, and we have about 3, 4, 5, 6, 7, 8, 9 methods that are inside of this particular class. So let's go ahead and look at what we are supposed to do first. So we are to write program code to declare the class vehicle. All attributes must be private. You only need to declare the class in this constructor. Do not declare any other methods. Use your programming language as appropriate constructor. Alright, so let's go ahead and look at the implementation that I have going on here. So here we have the definition for the class code vehicle. And the class definition is right there on line number 9. And of course, I'm using some doc strings here to document that this class represents a vehicle in a game. Of course, you could actually omit this. It's not really necessary that you pull it. Then we have the constructor for the class. And coming back here, you actually see that the constructor is going to initialize ID, max speed, and increase amount to the parameter values. So that's what we are doing right here. You can see that we have the parameters ID, which is of type string, max speed, which is of type int, and increase amount, which is of also type integer. Then we are initializing these attributes that we did pass here, right there on line 4, to the attributes for this particular object. Is it so the ID, the max speed, as well as the current speed, as it were. Then inside the constructor, we also have current speed and horizontal position, which are supposed to be initialized to 0. So that's what we're actually doing here on lines 9 and 10. Rather line 8 and 10, sorry, not lines 9 and 10. Line 8 and 10. So maybe what I can do, I can just rearrange this, cut this line, then paste it here. So for organization purposes. Alright, so lines 9 and 10 are initializing those private attributes to 0. And you would know that you are making use of private attributes in Python if you are using this underscore before the identifier names. Like for instance, right there on line 6, you can see that before saying ID, it's actually self.underscore then ID. So this is going to mark your variables as private in Python. So of course, having done this, you would go ahead and copy the code and paste it inside of the evidence document. So next up, we are supposed to write program code for the get methods, specifically get current speed, get increase amount, get max speed, and get horizontal position. So we have to implement code for these 4 get methods. And you see what these get methods return. So they return the speed, increase amount, horizontal position, and max speed respectively. So coming to our implementation here, it's spanning between lines 13 and 23 there. So I'll just explain this one, then the rest is actually the same thing really. So here we have the function header, right? Always remember to pass self as the first parameter in a method that you define inside of any class, right? Then we are annotating that it's going to return an integer. So this right arrow function is actually a hyphen and an angle bracket. It's pointing out that it's going to return an integer. Then of course we return self.current speed. Remember, current speed is a private attribute, so don't forget to put that underscore right there. So you're going to do the same thing for the 3 other get methods, as it were. And having done that, you can then copy the code and paste it inside of the evidence document. Moving on to the next aspect here, we are supposed to write program code for the set methods, set current speed, and set horizontal position. And if we come back here to the class diagram, you see that it's going to assign the parameter to the current speed, and then it's going to assign the parameter to the horizontal position. So these 2 set methods, they are going to take parameters, or they have a parameter definition, as it were. So coming to the implementation here, you see that we have the function header for this set current speed function, right? And you see we have self going on there as the first parameter always, because this is a function that is inside of a class. Then we are setting the speed, which is going to be of type integer. So this is an annotation that's going to describe the data type that's going to be expected for the speed. Then of course on line number 7, we are now taking the private current speed variable and overwriting it with the speed that was provided when this set current speed function was called, or will be called rather. So having done that, you can go ahead and copy the code for the set current speed and set horizontal position setter methods and paste them in the evidence document. Moving on to the next aspect here, we have item number 4, where we are supposed to have this method called increase speed. So what it's going to do, it's going to add increase amount to the current speed. It's also going to add the updated current speed to the horizontal position. So the current speed of a vehicle cannot exceed its maximum. So this is very important for later on when we implement this. Then we have to write program code for the increase speed function. So let's go ahead and look at that. Here we are just describing what the function does really, and you can see the function definition there on line 33. Then on line 35 we are taking the speed. We are actually implementing this logic right here. So we are saying that we should add increase amount to the current speed, is it? So what we are doing is we are making use, we are taking the current speed plus the increase amount, then the self.max speed. So what we're actually doing here is we're making use of this min function right here. So what this does is that it's going to return the smallest argument. This is how we're actually limiting the speed, as it were, for the vehicle object, as it were, because remember it said that the current speed of a vehicle cannot exceed its maximum speed. So in the event that the current speed exceeds the maximum speed, that's what we are simply saying right here. When we add this value, so maybe let me just type it out so you can actually see what I'm talking about here. So it works like this. We can have a value, then min, right? So I could have a minimum value of 10, and let's say this is 23, is it? So min is actually going to return the minimum value, which is 23 right here, for as long as it doesn't exceed max speed. But in the event that when I add the increase amount to the current speed, and it's going to be equal to let's say 96, is it? Then in that case it's going to return 23 and store that inside of this value attribute right there. So this is actually a built-in function in Python that simply returns the minimum value between two arguments that you would have supplied to your to the min function, as it were. So this ensures that even in cases whenever the minimum value is 15, 22, or any other value really that is less than 23, that's going to be stored as the current speed. But the moment it exceeds 23, then we are just going to cap it at the maximum speed, which is 23. So that's what's happening right there on line 36 there. Then of course here we are incrementing the current speed. We are incrementing rather the horizontal position to the current speed. So this notation, you might have seen it in the series. It's more like this. So let's say we wanted to increment a by b. We are simply going to say a is equal to a plus b, and the short end for it is to actually make use of the plus equal sign. So we can say a plus equal b. So this is line 37 right there is the same thing as line 36. So that's what we're doing there on line 38. Then having done that, you can go ahead and copy the code and paste it inside of the evidence document. Moving on to the next aspect here, we have B. Now we have another class right here called helicopter, and it's going to inherit from the vehicle class. So essentially here, we are extending the functionality of the vehicle class, but we are going to add additional implementations for this helicopter class, as it were. So this helicopter class is 3 attributes and 3 methods, and the 3 attributes are vertical position, vertical change, and maximum height. Then of course for the methods with the constructor, the get vertical position and the increase speed. So we have to write program code to declare the class helicopter. Just as before, we just need to declare the class and the constructor. So let's go ahead and look at that right here. So on lines 36 through 59, that's where we have the helicopter class. But for this part of the question, we just concerned with the class and this constructor. So let's go ahead and look at that. So the way we show that this helicopter class extends the vehicle class is to pass the vehicle class inside of these parentheses for the class definition for helicopter. So this is the Python syntax for showing that this class extends this class. Then on line 42, we have the constructor there. So you remember that the constructor, since it's extending the functionality of the vehicle class, the constructor is actually going to be the same. It's going to take the same attributes as it were, right? But immediately after finishing the constructor header, let me just bring this back right here so that you can actually see that it's part of the header. So you see that these attributes, they are exactly the same as what we have going on rather the first three attributes are exactly the same that we have going on for the vehicle class. But then if you come back to the helicopter class, you see that it has these additional attributes, vertical position and vertical change as it were. So those are what we have going on right here. Wait. Vertical position, then yeah, all right. So we have ID, then we have the max speed, we have the increase amount, which is basically the vertical position. Then we have the max height and the vertical change right there. So these attributes are actually going to be initialized inside of the super classes constructor. So on line 44 there, we are now calling the constructor for the vehicle class, and we are now passing the ID, max speed, and increase amount. That is exactly what we have in the constructor for the super class right here. So the super class is the vehicle class, and the subclass is the helicopter class as it were. So we are calling super there, then the constructor for the parent class. Then for the vertical change, according to the requirements here, we are going to, all right, where is it? Takes the ID, max speed, increase amount, vertical change, and max as parameters, initializes vertical position to 0. So here we are initializing vertical position to 0, then the vertical change, and these ones, they are going to be taken from the parameters and assigned those values there. So having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then item number 2, we have the helicopter method increase speed overrides the method from the parent class and adds the amount of vertical change to the vertical position, adds increase amount to the current speed, adds the updated current speed to the horizontal position. So the vertical position of a helicopter cannot exceed its maximum height. The current speed of a helicopter cannot exceed its maximum speed. Write program code for the method increase speed. All right, so coming to the implementation here, this is item 2 rather. So increase speed, you can see the function definition on line 53 there. Then again, we are using the minimum function because there's this constraint here that the vertical position cannot exceed the maximum height. So here we have maximum height and we are increasing the vertical position right here. So in the event that this vertical position is going to exceed the maximum height, then we can retain the maximum height. Otherwise, whenever the maximum height is greater than the vertical position, we are going to store that as the vertical position right there. Then the current speed of helicopter cannot, yeah, that's what we did take care of there. Let's see. All right, so for the increase speed method, the last thing that we need to do is we already have this increase speed going on inside of the parent class as it were, right here. So what we're simply doing now is we're now calling that parent class increase speed to handle the horizontal movement, is it? So because remember the horizontal movement logic is already handled inside of this super class right here. So we just call the super class function to achieve the same thing instead of having to implement it our own, because it does exactly the same thing. And that's actually one of the reasons why object-oriented programming is powerful. You can just reuse code where applicable. So having done that, you can go ahead and copy this code and paste it inside of the evidence document. Then C says that a procedure needs to output the horizontal position and a speed of a vehicle. If the vehicle is a helicopter, it also outputs the vertical position. All outputs must include appropriate messages. Write program code for this procedure. So we have a procedure called output vehicle details. So really, we have the function header, and it's going to take a vehicle object as a parameter, so it's of type vehicle. Then we are f printing basically, so we f print the vehicle ID, we get the vehicle's current speed, then we get the vehicle's horizontal position. So notice this vehicle is actually what's going to be passed as an argument when we call this function later on. Then if the instance of the vehicle is actually a helicopter, then we have to print the vertical position as it were also. But otherwise, if it is not a helicopter, then we're not going to print any of these really. So we just print a blank line after outputting the necessary information if it's just a simple vehicle. This only runs if it is a helicopter, as it were. So of course, you'd go ahead and copy the code and paste it inside of the evidence document. So the main program needs to instantiate a car as a new vehicle with the ID Tiger, a maximum speed of 100 and an increase amount of 20. So let's actually go ahead and do this step by step. So inside of main, we have a car object that's going to be called Tiger 120 for the maximum speed and the increase amount. Then for the second bullet point there, we are to instantiate a new helicopter code with an ID of Lion, a maximum speed of 350 and an increase amount of 40, a vertical change of 3 and a maximum height of 100. So you see that right there on line 77 there. With the helicopter object with attributes Lion, 30, 350, 40, 3 and 100 being passed to the helicopter constructor. Then call increase speed twice for the car and call the output procedure from 2C for the car. So let's do that right here. We are to call increase speed twice for the car, so we are doing that on lines 80 and 81, then eventually outputting the vehicle details right there on line 82. Then we are to write program before we do that, we also need to call increase speed for the helicopter and output the procedure from and use the output procedure that we did declare earlier on. So here we are calling the increase speed for the helicopter twice and outputting the details for the helicopter as it were. Then the last aspect requires us to test our program, so we are going to take a screenshot of the output after having run our program. So let me just pull up the terminal, run the program right here. And you see that we have the details there. So vehicle ID Tiger, current speed 40, horizontal position is 60, and vehicle ID Lion, and so forth and so on. So having done this, you can go ahead and take a screenshot of this and paste it inside of the evidence document. So that's just about it for this episode. I'll see you in the next one.